Good evening, students. How wanna do today?
Um, Fine so far. Just trying to fix a router for a bit.
Oh, okay, cool.
Doing
For the rest of it.
fine, sir. Having a good evening.
Oh, you're having a good day. Nice.
So if you don't hear me for a good while, it just me like resetting the router.
That's fine. How
Yes,
can
sir.
do
Brazil wins, so have a good day.
You're not having a good day, Arthur? Is it because Brazil won?
And me, sir.
Oh, sorry, Ashantia. Sorry, it was Ashantia. Ashantia, is it because Brazil won, you're not having a good day? Oh, no. I keep telling that you need to stop running after me, you know, honestly. Oh, goodness. Are you in a cast or you're on sick leave or just resting? What is it?
Them give me sick leave today and say I'm going to do X-ray tomorrow.
Oh, no. Sorry to hear, hon. I'm so sorry to hear. Osh, osh. So what were you doing though?
Tuesday I was putting up a trunket in the LRC with Solomon Brown. He didn't hold the ladder good, and I fell through the ladder and my right foot was bent.
Oh no. Oh no, that's not good. That's not good. You never hit your head?
Not everything, no sir. I thought everything was fine. But then when I got there, hit and everything was damaged on that. My foot was dent in. So I just laughed it off. The next day I came work. It was good. Then today I came back at work. My leg is swollen. And the apartment brought me to the doctor. And she kept feeling it and said it's a closed fracture.
Oh.
She needed an X-ray to see exactly what it is.
Oh no. So sorry to hear. Oh, please keep me posted here. Keep me posted, please. 1 minute. 1 minute. And without saying anything more, Pacific in class. Just keep for those of you who are close to the cross, just keep Leon in your prayers for me, please, also. And of course, Ashantia. Anybody else? Any joys, any concerns, anything else? The rest of them all right? Nike here, so far?
Doing okay.
All right, nice. All right, me a big one now. Just be safe here, because oh Lord, these things are just yeah. Anyhow, just be good, guys. Be safe. Please, during this U-tide season, if you have to be on the road, have a big one again, as I did sometime before. Please be safe. Nobody go up on the road and wear every piece of jewelry where you have. Right? Nobody try to look like no hot girl or no done man. Just go do it, look simple, do your thing. And come in your yard. Where you drew them in the yard and dress up at home. Because the man out there. Evil. Evil. So please, as I speak to you, I speak to myself. Just be safe. Again, nobody go up on the road with no cell phone and no hand and no earpiece and have no long conversation. Watch your surroundings. If you bend the corner and see you alone on the stretch of the block, turn back. Don't go alone. Them boys here out are wicked. and them don't care. Them only want to eat a food, and they will take your life just to do that. So please, be safe. I need to see you guys come January, God's willing, with a few pounds on your body. That way I know that you'll be well fed over the season. But of course, just remember the true reason for the season. That Master Father God come and was birthed to save you and me. Well, tonight is no different. I had a little conversation with Father God and say, should I, shouldn't I, should I, shouldn't I? And all I'm going to be saying to you is, please pay attention to your edible self. Yeah, that's it. I'm not saying anything more. Oh, one more thing. You see, for those of you who are moving, I see the movements. Congratulations. Congratulations. One day my spirit is just going to decide to close out. And when I do, things will not look so good in your favor.
Good night, sir. So, sir, can you close off before the date that we're seeing on Edicosoft, the 23rd of the 1st, 23rd to
The 20th, when is it the close of the
I said the 20th, I think I said the 23rd of the 1st, 2023.
Oh no.
31st of January.
Oh no. Oh no. Matter of fact, I
That's
should
not
change
it?
that. No. Oh no. That's not the close of. Oh hell no. Oh no.
Really?
No. Oh
That's
no.
what I saw, sir.
No. Hold on. Thanks for that info. Oh no. Maybe that's why people not moving.
serious,
Oh
sir?
no. The 23rd of January, the second semester would have started. Ouch. The second semester.
Because, sir, I keep on hearing you say closing out. And I'm
Oh,
confused.
So me I think of January when,
You come keep on here, sir, say I'm close we out.
I need to double check something because I mean, and funny enough, when Editor set up the stuff for me, I didn't even realize that it was a January end date. Assessment. Oh no. Whether or not, it's not a matter of you talking too much. Whether or not I would have, oh yes. This says the 31st of January. Oh hell no. No. I can tell you for a fact that that is not.
So sir, what is the correct date? If I don't mind asking.
The assessments will close out. Let me just double check that because I'm going to change the date now.
And we have the end of December, sir.
Yeah, man. What I will do is
January.
Nah, that's too generous for the assessments. Oh no. Today's which day? Today's the 21st. Today's the 24th. Okay. So 31st of January. What are you talking about? Crazy? No deal. I would have seen it. All right. I'm only being generous when I put it at the 3rd of January. And that too can change because the semester is going to end on the 17th. The semester ends
on what day?
On the 17th of December. So your last class with me technically is going to be December 15th. So yes. technically Edicosoft should be closed on 15th of December because that's when the semester ends.
But you say you're giving us until January 3rd?
I'm wondering if I should put it to the 29th of December.
No, like we get the holiday weekend. Remember, everybody work or most people work, so that break would be good.
Say that again.
So we
Remember,
kindly
most
ask for the third.
students are working, so the break, the New Year break, the Christmas break would be good.
Okay, so what day would you suggest then?
The third.
The
That was
3rd
good
or
to
the
go.
5th of January is fine.
That
Oh,
was
the
good to
5th
go.
of
What?
January. Oh, that's like
The
that's
3rd
like
or the 5th. The
the 3rd or
5th
the 5th.
is
All
a
right.
month.
But I say on the 10th.
All right. So what I've done, I put it on the 3rd. So if you check your Edicon now, you'll see that it's on the 3rd. So it's the 3rd of January. I need to venture over to my other course and just double check to see what is happening over there. See. What is happening there? Oh no, so they're also the 31st. So I need to go and put theirs onto the 3rd. The 31st is when the second semester would have long begun. Well, not long. Exams starts on 9th. I don't even know. We're not looking for the 3rd. So your exams will start the 9th and run up to the 20th. I'm not sure if you'll be getting it, but normally they give a 1-week break. Yeah, I think I should give a 1-week break. So school should start back on the second semester should begin the 30th of January. So it being on the 31st of January is a no-no. And trust me, as I tell you before, I am going to get those papers out of the way quickly. I pray to God that the exam is really on the first day, if not the second day. So I can be up and about. All right, so those are the, yeah, so yeah, so that is out of the way. All right, now into some other news. I
Start with the good ones first, sir.
It's all good. It's all
Okay.
it's all good. There's only one little bad in it. All right, let me start with the bad because it's just one bad. It's one bad. All right, so today is the 24th. I did say that the semester ends on the 15th for you. Your last class is on the 15th. I'm a little nervous because I have been moving rather slow with you guys, and especially with the differentiation. I should have already completed differentiation. But when I was doing my little oral exercise with you last class and was asking, so what's the differentiation of x squared? I'm hearing people tell me 1. And I'm hearing 1 or 2 people answering, and I say, boy, sir, 2x. Some people said 2. Don't know if those of you who were listening. And I was a little sad by some of those comments, because when I asked those questions, I should hear the differentiation reeling off your tongues. So they are, well, you see, I'm an honest teacher. I'm a very honest teacher, and I'm going to tell you from now. I'm a little concerned. I'm a little concerned that I'm running it close, and there are some of the last couple of topics that I may have to do. I may have to just run through those topics. So that is a bad thing. I normally like finishing the syllabus on time, giving you, and this is one of the reasons I'm insisting in doing past papers in class, because I don't want to just run through the topics. And it's a good thing that I'm doing it, because running through the topic is one thing, but getting your past paper practice is another question. Remember how when I started the first past papers, people were a little, what are these questions like? To the point where now people are doing questions and can get to a particular point in the question, right? So it means that you just need a little bit more practice to carry the question through to the end. So I'm saying it from now. I'm in a bind. I need help. I'm cutting it very close. I have not yet touched integration and its application. And I am in differentiation and awaiting to touch its applications. So technically, there are 3 topics that are left. The applications to differentiation that I am going to be starting today. Fly high, fly low. I must start that today. I will give you a host of questions to do. The questions are so repetitive with the applications to differentiation or cockroach. I have another application to differentiation question. So there are 2 applications to differentiation questions that I must start. I think I'll start the harder of the 2, so at least I can get that out of the way. So God's willing, come Tuesday, I will start integration and run through integration. Fortunately, I did a voiceover for integration a couple of semesters ago, could be maybe 2020 or 2021 for some students. I'm going to send you a copy of that voiceover. I think the voiceover does a little, Lord, can I find it? It's supposed to be in the channel, but the voiceover shows you step by step how to go through your integration. I'm going to send you that. I did a voiceover. So I'm going to send that off to you so that you can play it over and over and listen to it. I mean, you can send it as a WhatsApp to yourself on a downtime. You have a coffee break or your lunch break. You can take a, I think it's a maybe 5 minutes or so, or 10 minutes, whatever time it is, and just listen to the stuff. But students, really and truly, why I come to you and ask you, it's cutting it close. Now, that's the bad news. The good news is I will be working some past paper questions in class tonight again, for about the first hour, so maybe up until 8:30, 8:45 thereabout. So and those past paper questions will include the things that we would have done. We looked at 3 other types of differentiation the last time around. The exponential form of differentiation, the logarithmic form of differentiation, and we looked at the square. Did we do the square root, by the way? No, we never did the square root.
No, sir.
No, we never went up to the square root. All right, so let me just go through the square root. Thanks for that. I have started marking the papers. So far, I mean, it's not a wow. It's not like a 90% or a 95% from everybody, but based on what I've marked thus far, I see maturity. There's one student that I need to big up outside of class because, you know, I'm seeing the first principles differentiation questions, both of them correct to the T, and hear me thinking that you guys wouldn't be able to do the second of the 2 differentiation question. Sir, never you underestimate your students. So I mean, I was very pleased, you know, with that student. I need to look at the others, but I've started. So far, I'm not going to come in further because it doesn't look bad. It's nothing for me to be alarmed at just yet. So, you know, by next class, I'll be able to say, well, I'll send the papers to you before next class so that at least we can have a little conversation prior to the start of next class so we can discuss some of those questions. But for the most part, so far, you know, I am not, my feathers have not yet been ruffled, so to speak. And, you know, I can get a hot head sometimes, you know. I'm really, when I get a hot head, it's because it's for your benefit. I really want to see you guys become a success. It's not about me, it's about, all right, let me close that out. It's not about me, it's about you guys doing and doing very well. All right, so I had planned to start directly with the past papers, but no, remember that I didn't do the square root. All right, so while this document is coming up, let me ask you a question. When something is when something is square rooted, how can I convert that? When something is square rooted. So if I say, okay, let us use a concrete example, not something that is abstract. Let us use a concrete example. If I ask you to evaluate the square root of, what's the square root of 100?
10, sir.
10. All right, good. And you're correct. Well, partially correct. But yeah, I won't kill you. Half right. So the square root of 100 is, he says 10, half right. Can you, how did they arrive at that 10 without the use of a calculator? How did they arrive at that 10 without the use of a calculator? Okay, that's why it wasn't opening. Oh, come on, Sir Shan. How would they arrive at that 10?
Multiply by 10 by, oh.
Multiply by 10?
No, I said multiply the 10 by itself to get the 100.
Okay, but remember now, you know, all right, fine, that's a good start. Okay, that's a good start. And what next?
Raise to the power. Sorry.
Yes, I have those two. I have 1, 2. I said I have 3 topics, right? 1, 2, 3.
Yes, sir.
Yeah, man, I have 3 topics left. I just looked at this stuff and just double checking. Yeah, so I hear. Yeah, I hear multiply 10 by itself. But that alone don't help me.
So you convert the square root into half. So you raise the number inside the square root by half.
Excellent. I am going to buy. Have you had cheese strips yet? It's called cheese strips, right? But we call it cheese chips. Have you had cheese strips before?
I don't know.
You don't know what that is, don't?
No, sir.
Okay, so let me ask you this one. Have you had cheese curls before?
So I don't know the names of the cheese I eat.
It's not a cheese, it's a biscuit-like courage. Like a orange little thing in a bag that children normally eat. So it's not a type of cheese.
Like
it's
cheese
a type of
ball?
yes, you're correct.
Yes.
Other type of cheese balls.
Yeah, like cheese balls, right? I'm going to buy a whole bag of those courage. A whole bag of them. I'm going to buy. By the way, you like them?
Yes, sir.
Okay, I'll buy a whole bag, one whole, and don't give Lottie none, don't give Tariq none, no give none of them none. It is for yearns alone. But yes, very good. So what she said is that you're going to raise it to the half power. So this is it. I want all of you to, oh Lord and Father, this is, all right. Are you seeing my screen, by the way?
Yes, sir.
Yes,
Okay,
sir.
okay, great. All right. So, so I was saying 100, and I'm trying to find the square root of 100. No, I'm hearing a suggestion, sir, it's 10 times 10. I don't have a problem with that because 10 times 10 will give me 100. So what the suggestion was is to work out this 100 under the square root sign, not a problem. So that can be written as 10 what? Ten times 10 is 10 written like what? As an index.
2.
10 to the square?
10 to the second power. Very good. 10 to the second power. All right. Now, look at this. The square root sign, whenever you have the square root sign, when you convert it, it is something that is being raised to the half power. Every single time. The sleeve of the square root there in red remains blank. Remains blank. You do not say, or you shouldn't say, the rain is falling, because the rain can only fall. So it's really not correct or standard English to say that, oh, the rain is falling, because it has nothing else to do but to fall. So the correct thing to say is, it is raining. Neither do you say, repeat that again for me, please. Because to repeat, it means that you're saying something again. And again, you wouldn't say, reverse back. Because to reverse, it means that you're going back. So all of those in the English language is called, they're called redundancies. In mathematics, we also have those. So this is one such redundancy that we don't use in mathematics, by putting a 2 inside here to say it's a square root. No, it is not correcto. So when you have it blank, it is understood that it means that you're finding the square root and that there's an imaginary 2 inside of it. Now, if there is supposed to be another number other than 2, they will write it. This here now means the cube root, not the square root. It means the cube root, and the cube root will be over 1/3. And this here would be the 4th root, and the 4th root would be raised to the 1/4. You get the gist yet?
It's very odd, but I get the, I think I get the style.
What is odd about it?
Sir, sir, can you go again, please?
Okay, what is odd about it, Crosswell?
Oh, just looking at it, if you looked at it without any context, it would seem confusing. But as I understand it, you're merely just rewriting how you'd write the values. So instead of just simply writing the square root, you would simply write it as it being multiplied by what's the term now? A fractional as I understand.
And you're not correct, because I'm not multiplying anything back in a fraction. What am I doing?
Exponent.
I'm raising it. Yes, an exponent. It's an exponent, Crosswell. It's not a multiplication. It's an exponent.
So you mean like sorry, you mean like what we did last class?
It's an exponent. So when you have the square root of something, and this is, let me just finish this question so that you may see what is happening here. Let me finish this question. So what is now happening here? This is going to be 10 squared raised to the 1/2 power. Recall, a to the m raised to the n is equal to a to the mn. When I have a base raised to a power, which in turn is raised to another power, the rule says I multiply both powers. So 1/2 times 2 equals?
1/2 times 2.
2 halves make up?
A whole.
So it's going to be to the first power. And anything raised to the first power, recall again. A to the first power is simply a. So it means then that 10 to the first power is really 10. Then, sir, Tariq said the answer was 10 and he said that he was half right. Can anybody suggest why he's only half right?
Oh, from what I'm seeing, you didn't specify the exponent first before you wrote your final answer.
That's not it. That's not it. Why is it that Tariq is not right? Fully. He's only, and I'm still maintaining that he's only half right. Why is it that he's only half right? Anybody, somebody?
It's his only.
So
Well,
calculate.
Add 10 to the first power.
Say it again.
So
Talk to me now. So Charlie gave me an answer earlier. And I was like, yeah. No, you're on a half right, son. Why is it on a half right for me? Talk to me.
So
okay, let me give you a hint. How can I check my answer from here? I'm getting the square root of 100 to be 10. How can I check my answer to know that I'm right?
Yes, square root of 10.
And when I square root of 10, what do I say?
when it's squared,
10 times 10.
10 times 10. Ah, I love that. Stay right there. Stay right there. I love that. Excellent suggestion. 10 times 10. Very nice. All right, now. And you recognize that both signs are the same. So 10 times 10. Is there another set of numbers that I can multiply together that would give me the same result as 10 times 10?
Yes, sir.
What? What is it?
5 and 20.
All right, Rajay. So here's my question to you. All right. Okay. Look at what I'm talking. Oh yeah. So you're correct. 5 times 20 is 100, but that's not the pair of numbers I'm looking for. All right. So
wait, sir. So since you bring that up, since you bring up pairs, I believe that that has significance as to why you wanted the answer in that particular order. So you said Tariq said that 10 was the incomplete answer. And then you wrote down 10 to the first part, and you wrote another 10. And then after that you asked, how do we check to see if we get back 100? So based on that, what I'm seeing is that is it I'm just making an assumption. You need your pair of terms to be what's the term now? Compatible, no, not compatible, equal to each other in order to get the original value which you made the square root of.
Yeah. Yes to your question. Don't know if Rajay heard that, but yes. Go ahead, son.
Sir, that's why I have 3 lines for the first line as an equal sign. So you have that's strictly equal to the square root.
Oh no. The 3 dashes mean equivalent. So the 3 dashes mean equivalent. And when I have 2, it means equal. So it is those 3 parallel lines means equivalent to. And of course, the 2 parallel lines, the 2 lines will mean equal to. So equivalent means that I'm only writing it in another way. So for example, I took $150 Jamaican dollars from you, but I gave you $1 US. Somebody may say, no, you took $150 and you only give him $1, you thief. What I would have done is to give you the equivalent, the equivalence of the US dollar or the Jamaican dollar, vice versa. So I'm saying to you, the root of 100 is equivalent to the root of 10 times 10. And then I'm working from there now. I'm working from the right-hand side, 10 times 10, and I'm working it down and I'm working it down. So based on what it is that you said, Crosswell, anybody get any suggestions? Rajay, were you listening to Crosswell? So yes, that would have to be the same thing. And I'm going to tell you something secret.
Also, I noticed another thing. When you created the equivalence, I want to make another assumption. From the moment you make the equivalence, should the final answer represent the equivalence?
The final answer is representing the equivalence.
All right, so
okay, it represents one of them because I recognize I had 10 times 10 in the for the equivalent, so to speak.
yes.
And then I'm only using one of them. Yeah. So if that's your observation, yeah, you're correct. If that's your observation. But come on, this is taking longer than expected, man. Talk to me. What two same numbers do I multiply to give me 100?
10 are the two same terms that you multiply together to get an original value from a square root.
What else? What else? Maybe I'm not asking the question right. What else?
But they can multiply together 25 and 4.
Same.
But want the same numbers, the same set of. Yeah.
So
-10, sir.
Okay. So just -10? -10 times who?
Times -10.
Very good. -10 times -10, yes. So remember now, Satar, whenever you are finding the square root of a number, you must take into consideration the positive root as well as the negative root, because the square root of 100 is not just 10. The square root of 100 is plus or minus 10. It could be a positive number or it can be a negative number. How, sir? Because when I multiply -10 by -10, I'm going to get positive 100.
Well, to the first part.
Gotcha.
Yeah.
Remember
Go ahead.
the first part, sir, because if you just put -10 times -10, you just get a -100.
No, you can't get -100. That's wrong. When I multiply two negative numbers, I get a positive number. Always remember that, Crosswell. Whenever I multiply two negative numbers, my result is always positive. Yesterday, today, and will forever be. So now I multiply the rule is, once I'm multiplying two numbers and the signs are the same, my result is positive. So two positive numbers multiplied together will give me a positive number, and two negative numbers multiplied together will give me a positive number. The rule only changes when one of the numbers is positive and the other number is negative. Everybody see that? That when you find the square root of a number, is actually the positive root as well as the negative root?
Yeah.
Yes, sir.
Yes, sir.
Yeah, man. Real talk every time. So it's always a positive root as well as a negative root. All right. So didn't intend for this to be this long, but it's important for me to do this stuff. So Croswell said that it was odd. There's nothing odd about it. So if you look at it, if you look at the screen, you'll see the square root is going to be equal to the term raised to the 1/2 power. The cube root is going to be equal to the term raised to the 1/3 power. The fourth root is going to be equal to the term raised to the 1/4 power. Oh, sir, like duh. The fifth root is going to be the term raised to the 1/5. Very good. So in general, the root of n is going to be equal to the term raised to the 1/n. That's what it is. That's what it is. That's what it is. All right. So since I'm in this modality, let me just generate some fresh questions out of my head until we've touched the past paper ones. So let's go. So let's look at some examples. So if I say to you, find dy by dx given y is equals to the root of 2x plus 1. Wow. Sir. Oh, but sir, you did say solution. So you did say that if y is equals to the root of 2x plus 1, I can write something to say y is going to be equal to 2x plus 1 raised to the 1/2 power. Do you all agree with that?
Yes, sir.
Very good. That's the first conversion, and that's where I'm going to start. Hold up, sir. What rule do I use for this one? To differentiate.
Power.
Every time. The power rule is always used when you have a term raised to a power greater than or less than 1. The only time I don't use the power rule is when everything is raised to the first power. But in a case like this, my dy by dx is going to be equal to, remember the power rule says you take the power and multiply by the something here, so, and you reduce the power by 1, minus 1/2. Talk truth. A half minus a half minus 1 equals?
Minus a
Half.
Negative a half, orange. Right, negative a half. The rest of you see it?
Yes, sir.
All right, cool. Am I finished right there?
No.
What do I do?
You need to multiply the
multiply by the?
What is in the bracket?
Multiply by what?
The differentiation.
The differential of inside the bracket. Very good. What is the differential of inside the bracket?
2.
Very good. Very nice. Very nice. Come, I want you to be quicker than that though. 2 times a half?
That'll be 1.
Equals 1. All right, very good. 2 times a half equals 1. So dy by dx is going to be equals to 2x plus a half to the negative 1. Nobody don't ask me where the half is and where the 2 is. Where the half and the 2 gone?
So 1.
There's a 1 here.
You see the 1.
You see the 1? You see the 1 now?
Yes, sir.
I put the 1 in blue. Did I have to write that 1 in blue? Say no.
Oh.
Yes.
No, sir, not for it.
Yes.
You're not right, sir.
I don't have to write it. So those of you who say yes, then lose 1 point. All right, so I don't have to write it. All right, so let's go. Now, just as a side note, well, a little bit more than a side note, we never normally write or in mathematics, we are so positive in thinking. We are positive thinking people. We never normally write our answer as a negative index. So let me recall something for you one more time. Recall. A to the negative m is equals to 1 over a to the positive m. A to the negative m is equals to 1 over a to the positive m. So in order for me to make that index positive, I'll have to reciprocate the whole thing. I'll have to reciprocate. So a to the negative m is going to be equals to 1 over a to the positive m. So my dy by dx now is going to be equals to 1 over 2x plus 1 raised to the positive half power, or I can write it as 1 over the root of 2x plus 1 as my answer. I know somebody can look at that and say something to me. Look at it.
Give about the same answer.
Say it again.
So you got about the same answer.
Me didn't know somebody can say about the same answer. Is it the same answer?
No.
No, not
Okay.
actually, but you get the point.
I don't get no point.
Sir, we're just getting just over 1 though.
All right. Somebody can answer another question. Please don't disappoint me. It happens every year.
What's the other question?
Yeah. No, there's another question that students normally ask. Let me hear if I'm going to hear it this year. So the question that you asked, Jojo, is one of the questions that, or the observations that students always often gives. All right. But there's something else that normally follows through with what you just said. So I'm waiting for it. Don't disappoint me. I'm not going to tell you because I know it's going to come out.
So you say it now, simplify more than that.
No, man, that's not the question. But no, that one I can't simplify. but another question they do. But no, that can't. That's the furthest. That's the lowest that can go.
Sorry, mortality like.
Put back the square, so where's the half?
Say it again.
Right off.
Question is probably say where's the half?
Where's the half? Oh, I just reconvert it. Remember.
No, sir. I'm just saying the question.
Oh no, man. That's not it either. Oh no, that's not it either, hon. That's not it either. It soon come out, man. It soon come out. It's going to come out. I guarantee it. It never fails that every year these questions are asked. And incidentally, this is how CXC is able to write so many multiple choice questions because they know the general misconception from students, and the multiple choice questions are written to address those misconceptions. So, yeah. But if I don't hear it, no, that's fine. Oh dear, forgive me.
Christ. Yes, suffer on.
All right. Are there any questions? I will let you know when I hear the questions because I know it's gonna come.
All right, so just answers for now. I think Latario, one of them, one of the probably answers already. You just you're right. Y is equal to square root 2x plus 1, and for the answer, when you rewrite the statement, it's basically the same thing. So for questions like these that deal with the square root, would we have to rewrite it as close to the original statement as it is?
What the answer you're talking about?
Yes, that's what I mean.
Okay. So thank you for asking my second question. It never fails me that those questions are asked. So technically, it follows from what Jojo asked. Yes, there is a similarity with how the question looks. But students will ask, oh, sir, then the question not gonna look like this, so we just put one over the something or something of the sort. No. Sometimes the question looks similar, and there are times the question will look like them in malice. So I don't want anybody from this one question that I would have done thinks to themselves that every time you get a question like this, it will turn out to looking something like this. No, it don't work so.
Oh, just wanted to confirm because I remember you said at least in one of the classes like say.
Yeah, so that is a second. That is a second. So I should have done this because I know it's going to give me problems to do. Oh, come on, Mr. Shan, why didn't you do that? Yeah, okay. Yeah, so it is what it is. It is what it is. All right.
So when would we know to rewrite the answer as the original close to the original question then, sir?
When would you know? I don't understand that.
No, I mean he said that this type of question is an outlier. So and you mentioned like so one of the previous classes in because I think but it was a different topic, so I guess it won't work the same. No, never mind my question.
Okay, because I was about to tell you that you say everything in John up a while ago. I don't hear one thing you said, but never mind. You said never mind, so let us leave it alone. All right. So that was just one example that hopefully shows what it is that we're talking about there. Let us look at another example. Example 2.
Sir.
Yes, please.
The answer of that example would be completely different from the statement of a question. Would look completely different. Is that the goal?
No. The point I'm making is when I do, okay. Hold that question. Hold that question. How do I solve this? What method do I use?
Sorry, I would use a power rule because you know it raised the water cell.
I wouldn't use a power rule. Okay, I hear that. I wouldn't use a power rule. How would I go about doing this question now, guys? Talk to me, quick and fast. What rule do I use?
Exponent?
No. What rule do I use?
So I'm guessing the chain rule.
No. What rule do I use here?
So the quotient rule?
If I knock you, say pick the child.
So that's okay.
Sure. Tell me to correct something, no man.
There's only three rules that
Is
come.
it the power rule, sir?
No.
There's only three rules that comes with differentiation. You have the quotient, power, chain.
How many terms you seen right there, sir?
Two.
Two terms.
And what that one got to do with that one, yeah?
Sorry, repeat that.
What this is the first and this one is the second. Which rule talk about first?
There is a product rule, sir.
Product rule, yeah.
That's a product, you said no.
Somebody said you said product?
Yes, sir, you said no.
Miss sorry.
I said no. I said the product rule.
Miss you know what I hear? I thought it said the power rule.
No, somebody said the power, you said no long time.
Okay. Miss sorry. But yes, the
I'm
product
on the page right here, sir, and I read it and it said first times. That's why I said.
Yeah, man, product rule. All right. So you see what it is that I did right there? I rewrite the root of x plus 1 as x plus 1 to the half. So every time I get the question, I have to do that? Yes. Yes. So let's go now. dy by dx. dy by dx, the first times the differentiation of the second. Now, Jojo, you said that it's not the power rule. You said that it does not include the power rule. That's what you said, right, Jojo?
Yes, I think somebody said that.
Yeah, man, that's what
But
Jojo
we
said.
didn't have the half because the half is
So when you get the square root questions, them going to always include the power rule because you're going to raise it to the half power. All right, so it's going to include the power rule. So this one is going to be a half times x plus 1 to the negative half. Huh?
Why is it a half?
Somebody tell her for me, please.
Whenever you have
squared.
And you rewrite the statement, you always put a half.
Look here. No, just look up here, sir. No, just look right up here, sir. When you have one square root, it is going to be the term raised to the half power.
Term squared.
I'm not talking about that, no, sir. I'm talking about the differentiation.
You're talking about the differentiation?
Yes, sir.
No, Joe, it cannot be. That's what you're talking about. It has to be this one that I just introduced to you here, because this one that you're asking is something that we did from about 3 weeks back. How do we differentiate?
Sir,
Let
can you
me
just quickly scroll back to the top, please?
I need to take
Okay, sir, thanks.
Wait, hold on before I move, sir. Let me just take a snapshot of this. All right. Thank you, sir.
You're welcome. when we are differentiating the power rule, when we're differentiating anything, y is equals to x to the n. dy by dx is equals to what? How do I find dy by dx, Jojo? Come on, Jojo, talk to me now.
Sir, I don't know.
I'm not, like seriously, Joe, don't play with me. What do you mean you don't know? Joe, answer my question, please. If y is equals to x to the n, dy by dx is equals to what?
Sir, x to the n.
Wait, what?
nx minus n minus a.
1 over nx, 1 over n, 1 over n.
Oh, Jesus.
The number
S to the power of n
minus
minus
1.
1.
Thank you, Courage. On a now learn, you know. On a now learn. On a now learn. I'm gonna get very upset now. On a now learn. How long now have I started differentiation? That was the very first thing that I did in different. That's the rule for differentiation. Y is equals to x to the n. Therefore, dy by dx is going to be equals to n x to the n minus 1. I went as far as saying to you, let me see if I can draw this. Let me take off this thing here because it's slowing up my stuff. I went as far as saying to you that this n is going to be used to multiply down here, so, and I'm going to subtract 1 from the power right here, so minus 1. So that's why I have an n in front of here, so. And that's why I have the n minus 1 here. I'm reducing it. So y equals x to the n, dy by dx is going to be equals to n x to the n minus 1.
I remember the multiplying it by the what's the name of the power. It's just that I kind of what's the term now? I kind of blew the fuse for a bit, so it hit my mind for that second. We did do it already, so yeah. Like it just never really say the same thing that I do.
I can take a picture of it out of my book and send it to who don't have it.
Marv it.
No man, no, not you, Crosswell. Please and thanks, I'm not told. So this is the gravamen of my concern, students. Georgia is not the only one in class. There are others in the class who don't know how to differentiate. And because I already sense that, I'm unable to move where I want to move to. So Joe may be getting the full brunt of it because she's brave enough to answer or to ask. But there are others in the class who are not getting it. I'm glad that Jojo asked the question. Thank God she asked it because me don't know myself. I'm not she alone, sir. Me don't know it neither. And I'm saying to you, students, the exam paper set already. And I cannot stay on this for much longer. Otherwise, I'm not going to finish the syllabus. Come on, students, please, I beg of you. All right, so let's go. So y is equals to x to the n. Dy by dx is going to be equals to n x to the n minus 1. And part of the problem, you guys not taking up your math books.
No, sir, that's the problem.
And you know why I don't send you, you notice what sir has done? And let me just confess something to you. So in my preparations for class, it's like what I'm writing here on screen. I would just sit up and just make up questions and do the solutions to the questions. Do the solutions to the questions. So when you come to class, I can just project my my solutions, my question and solutions. And what I normally do at the end of the class, I will just take that and I'll just WhatsApp it to the students and give it to you. And let me tell you what I surmise. That students just come to class and just sit down and just look. And say, all right, because Sarah go send it afterwards, me get it. And I don't know if you remember earlier on in the semester, I said to you that I'm not sending you the notes. Anybody remember that?
Yes, it is, sir.
Okay. And this was the very reason that I'm not sending it to you. I can send it to you because I have them. But what I'm trying to do is to get you to be more participatory in class. Something that I failed drastically. Fail it, bad. So like what I write in class here now, I will send to you. Because every time I'm preparing something, I write a one question and I have it. I mean, I have electronic copies of the stuff that I sit down and prepare for you. I don't come to my class unprepared at any point in time. I may come to class not feeling well, but I come to class fully prepared. When you guys sleeping, I'm up writing, okay, let me just make up a question or two, or I write a question on paper and then type it, save it. I said, all right, this is what I'm going to do in class today. I have them, but I can't send them to you. Because when I send them to you guys, just sit down and just get the notes. Sorry, send this for me, please, sir. Sorry, you can't send back. No. You're supposed to come to class and try and get it. All right, let's go. Am I finished right here, sir? With a half times x plus 1 to the negative a half?
No.
What is left?
So the differentiation of the first.
No, something else is left. What am I supposed to do right here? No, Lord. Oh, Jesus, I pray that you send an anointing on them, Lord. What? Okay, let me tell you. I'm going to be multiplied by the differentiation of the inside.
Times the differentiation of the first.
No, I am multiplying by the differentiation of the inside here. So remember that I have to differentiate what is inside the parentheses. Remember the power rule?
Oh, yeah, you don't find that yet. Yes, sir.
Right, so I have to differentiate. Then, sir, you're going to for another one. Try get it from no. So if a 1 or 2 or 3, try remember. So we have to multiply by the differential of what is on the inside. Then now I'm going to have plus the second times the differentiation of the first, which is
2.
2. All right, which is 2. And then now, dy by dx is going to be 2 times a half equals how much?
1.
And 1 times 1 equal?
1 times 1.
And 1 times x equal?
X.
Good. So it's going to be x times x plus 1 to the negative half. Let me tell you why I'm laughing. And I'm not laughing at you. Because let me ask a question first. Sir, where the 2x gone and a half? Let me see it before you ask me. 2 times a half times 1 equals 1. And the x is written back right here. And of course, my x plus 1 to the negative a half is right here. Can you agree with that?
Yes, sir.
And this 2 is here, and this x plus 1 to the positive a half is right here. Work with me. Mm.
No, wait, no. Sir, speaking of that, sir.
Go ahead, sir.
In some examples that I saw in regards to the differentiation, they would single out, like say, the numerical values, and say, like say 2 times half and times 1 and those type of things, or times 0. And they usually, and beside them, they usually put, like say, the dy over dx symbol to show it. So your thing is remind me of that right now.
Okay, yeah, man. So it is the same thing. It's just like I refuse to write it. This is calculus 1. Well, I shouldn't say I refuse to write it because I did highlight it by circling the 2 times a half times 1 to give you 1. And I wrote the 1 in blue. Let's go. I have 2 terms. X times x plus 1 to the negative a half. And the other term is 2 times x plus 1 to the positive a half. Is there anything common between those 2 terms?
X plus 1 to negative a half.
Why to the negative a half and not the positive a half?
Right. I wasn't giving the answer, sir. I was simply trying to figure it out.
Okay. So may I have an answer, please? What is common?
X plus 1. X?
No, it has to be x plus 1. That's one of the 2 things that are familiar between the 2 expressions.
Do me a favor, guys. All of you. It's now 24 minutes past. I'm going to ask that you go find a bottle of room temperature water. Every one of you. And I want you to drink off the whole bottle of room temperature water. And I want you to walk. Get up and walk. Just get up and walk and clear your minds. Because I ain't in a good mood just now because you guys don't remember what to do. Clear your minds. I'm giving you 6 minutes to drink off that bottle of water. I'm going to do the same thing too because I think my BP is just raising now, so I need to kind of cool it down. Pausing for 6 minutes, drink some water, we'll come back at 8:30. Oh, and incidentally, when I come back at 8:30, I want to switch on the serious button here. I don't want the joke button, I don't want it to be on. Thank you.
Latoya, mute your mic, please.
Somebody was calling Latoya.
Yeah, I was saying to mute the mic.
Are you hearing me talking?
No.
All right. Always stay now. Anybody? When you come back yet?
So we're going to sir.
So I think what's common is x plus 1 raised to the power half.
X plus 1 raised to the power half.
I was checking it over, and one of the things I realized is that in regards to x plus 1 and the two terms, we could I don't want to say it because I don't want to sound stupid, but I was checking it over, and I remember that there is a thing called the sum difference rule, sir.
Okay.
So I would just try and use a to see how I would get reach the next step.
May I ask a question, please? What class do you have after? What class do you have after Calculus 1 on a Tuesday?
Okay, so we have one after.
Is it administrative com?
Yeah.
Sir.
Yeah.
Who teach it?
Miss Alice. Miss Speed.
Miss Speed.
Dennis Speed?
Yeah. Dennis Speed, sir.
Yes.
Okay. I'm gonna have a conversation with her to see if she'll be willing to come in and do a 7 to 9 class on campus, because I have to meet you next Tuesday for a face-to-face class. It now work out. 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 I prefer to do the Tuesday because if I do the Thursday, I'm not going to stay there beyond 9 o'clock and I'm going to be losing an hour. So I'm just letting you know that I'm going to be asking her. If she says no, I'll have to relook at it, because what I don't want to happen is that I have a class there. I don't want to be selfish to have a class at 7 to 9 and then you guys have to commute and have class while commuting for your 7 to 9. So if she's willing to come in on Tuesday for a face-to-face at 7 o'clock to 9 o'clock, I'm gonna have you face-to-face on Tuesday, God's willing. Because this is not work out. Not work out. Not work out. Not work out.
Sir? Sir, all right, so what do you require of us? This is just the next step as it relates to the first term.
What I require of you is that I want you guys to start learning. Not just in accepting a papa. Oh yes, I gave you homework. Oh yes, I gave you homework. I give you homework. Let me go again. Square root function. Whenever you're presented with the square root function, first rewrite the function raised to the half power. That is x raised to the half. Recall, the nth root of a is going to be equals to a raised to the 1 over n. The nth root of a is going to be equals to a raised to the 1 over n. Similarly, if I ask you to evaluate the nth root of a raised to the m power, it's going to be, in the first instance, it's going to be a to the m raised to the 1n, 1 over n. And recall, a to the m raised to the nth power, whenever you have a base raised to a power, raised to another power, you multiply both powers. So I'm multiplying m by 1 over n to give me m over n, to give me m over n. As I was drinking my water in the kitchen, I don't know why this song came into my head, that I must drink water and mind my business. And I really can't mind my own business, because my business right about now is your business, and your business about now is mine. Please note, whenever or whatever is in the sleeve of the square root sign will be replaced as a reciprocal power. I told you this before. See, everything here that I have in my personal notes, I was presenting to you out of my head again. See it here, so? Y is equals to x to the n. It implies that dy by dx is going to be equals to this n come in front of, see it right here, so? And then I'm reducing the power by 1, see it here, so? N minus 1. So work with me. Y is equals to the root of x. Y is equals to the root of x. So I'm going to let y be equals to x to the 1/2. Why, sir? Whenever I have the square root, it means raised to the 1 over 2. It means that I'm going to raise it to the 1 over 2. So dy by dx is going to be equals to take this half, multiply it in front, see it here, reduce a half by 1. Now it becomes a half minus 1, which is negative a half. Any questions so far?
No, sir.
So note, like I've shown you before, a to the negative m is equals to 1 over a to the positive m. We always reciprocate to obtain a positive result. Anything here in my notes differs from what I was doing on paper with you a while ago?
No, sir.
Okay. So look at what is going to happen now. Because I don't want this negative 1/2, I am going to reciprocate. So I'm going to have 1 over x to the positive a half. See here, so? The half remains, This 1 over 2 here remains, And then I'm going to have 1 over x to the positive a half. See here, so? 1 over x to the positive a half. When I'm multiplying two fractions, watch me. When I'm multiplying two fractions, I multiply the numerators, and then I multiply the denominators. 1 times 1 is 1. 2 times x to the 1/2 is 2x to the 1/2. But remember, the 1x to the half can be written as the root of x. So I'm reconverting it, and my answer is going to be 1 over 2 the root of x, because the root of x is 1/2. Sir, how you know that? X to the 1/2 is equal to y, but y is equal to the root of x. So my x to the 1/2 is going to be the root of x. This is my final answer. Are there any questions to this question?
No, sir.
Okay.
Sir, I have a question.
Go ahead, Papa.
Sir, don't beat me if I'm wrong, but it was a question. Is that the chain rule?
No.
Okay.
This is a power rule in its entirety. This question is a power rule question. Remember, the chain rule is something plus something minus something minus something plus something minus. You see? So the chain rule is things adding or subtracting from each other or to each other. Things adding to each other or being subtracted from each other.
So that would involve.
You get me?
Okay, sir. Yes, so that's a power rule. All right.
I don't think you get me fully. So the chain rule, and incidentally, I won't get at you, and I don't want anybody to say, me not ask you no question because you need to get at me. No, that's not the idea. I may speak strongly because I want you to know what it is that I'm talking about. What I also want you to do is to ask me questions in class. How much time I come class and ask? How much time I come class? How many times have I come to this class and asked you to talk to me? Have I ever invited you to speak to me in class?
Every time.
Yes,
every time.
Every class.
Okay, let me ask you one very important question. Is there anybody who is afraid to ask me a question in class? I heard that. But seriously speaking though, I want to be serious. Anybody's afraid of asking me a question in class?
Sir, no, you're not eat people.
What I don't do?
Sir, man, say you're not eat people.
No, but you see, I'm just wondering why people don't ask. So if when you ask me the question and I speak strong, it's not that there's any love lost, but we want to know if we catch the something.
Sir, to be honest, sir, I'm still completely with our previous teacher. So
we in this thing too long now. The 26th of September, October. No, we're in this thing 2 months now. So it can't. It may be different, but no, man. On a serious note, I have created an environment or tried to create an environment. Don't know if I've failed, where people should feel comfortable to ask me a question. You should feel comfortable to ask me every night. I come and ask you, and if you never want to never ask me a question, you want to invite you to do it. So if you're not going to come to class, and when we have a face-to-face class, if you're not come to me the foolishness, we're going to rub on hard too. This is a part of learning. It's a part of learning. But you don't have to go talk up, man, because it now work out. Anyhow, so Dan, what I'm saying to you is when things are being added or subtracted, that's how you identify the chain rule. When things are being multiplied, that's how you identify what rule?
The product rule. And when things are being divided, that is the
quotient rule.
Quotient rule. So if you don't say any numerator and denominator, try not to use quotient. It not work out. And I told you how to identify the power rule. The power rule is when you have something raised to one power, and the power is not one. If the power is one, you really don't have a power rule. Any other power other than one, then you have the power rule. And then you have the power rule. All right, let's go. I know that I gave you a question, but I'm pressing pause with that question. And I'm presenting a question that is very similar to the question that I posed just now. Y is equals to the root of 2x plus 3. Work with me. Y is equals to the root of 2x plus 3. I'm going to let y equal 2x plus 3 to the 1/2 power. Agree?
Yes, sir.
Power rule. Power rule. Power rule.
So I want to ask a question.
Go ahead, man.
I'm seeing a pattern. I see that when you rewrite the dy dx, I realize that the half turns to negative.
Yes. Why?
I'm not sure.
All right, no problem. You soon see it. You soon see it. I'm differentiating.
Yes, sir.
Dy by dx. This 1/2 is going to come in front. You get that?
Yeah, I know that. I know that.
Boom. Good. We catch that one day. Then we're getting right back the 2x plus 3 in your so.
Yes, sir. I know that.
But we have to reduce this by 1. So it's going to be a half minus 1. What is a half minus 1?
Minus a half.
Yeah. That's how we get the negative a half. And then now we have to multiply by the differentiation of the inside of the parentheses, which is 2.
It is 2.
See the times 2 here? So the differentiation finish in blue. Watch me. Which is the same thing like I did when I was writing. A half times 2 equals?
Half times 2 equals
1.
See the 1 right there, so?
1, sir.
I didn't have to write the 1, but I put the 1 in blue. All I'm going to be left with now is 2x plus 3 raised to the negative 1/2 power. We never normally write or find an answer as a negative index.
Sure.
Go ahead. You have a question?
Sure. Yes, sir. So why did we multiply the half and you go all the way over the 2? The half times 2 and not the half times the 2x.
Watch this now. You see this 2x plus 3?
Yes, sir.
Is the protection. It is being protected by this negative 1/2 power.
Oh, yes, yeah. I see.
Yeah, this 2x plus 3, nothing can touch it because it is being protected by this negative 1/2. You remember BOMDAS? So I can't touch inside. The only way I can touch inside here is if this was raised to the first power. Other than that, I can't touch it. It's being protected. Nothing can get into it.
Oh, so if it had another power like 2 or 3, I can't touch it either.
It's still
just
can't
one.
touch it. It's just
one.
One. Yeah.
Yes, sir.
Yeah. So remember, guys, thanks, Mikey. Remember, I cannot multiply this 1/2 or this half here by this 2. Why, sir? It is being protected by this power. Then so you could have multiplied if it was a positive a half? No. What if it was 1? Or what if it was 1? Yeah, if it is 1, remember, if it is 1, I don't have to put it in parentheses either because it's just raised to the first power. So if it is 1, I can do anything that I want to do with it. But once it's anything other than 1, I have to respect it. It is protected. It is protected. All right? So this half, what I'm doing now is everything around this protected stuff, I am multiplying together. And you'll see that I do this every single time. So half times 2 is 1. And I'm writing back my 2x plus 3 to the negative 1/2. We can't touch it. Leave it as it is. We don't leave our answer as a positive, as a negative index. So I'm going to put it as being positive by reciprocating. Remember the rule? 1 over the same thing, but except now that it's going to be to the positive number. So it's going to be 1 over 2x plus 3 to the positive 1/2. to the positive a half. Question. All of you are in the same administrative class, or you're in some of you are in a different group?
Sir, I don't do
But
that.
all of us suppose, but it's a mixed group. I know some other persons from other departments are in it, are in the admin com.
Oh, but all the computer students.
Me say,
Here,
I have a problem because so many people them overseas in an admin.
Granted. Sorry, that's not a good word to say online. Oops.
Tourist people them and all that, tourism people them and them people them.
Yeah, the tourism students are away. Yeah, that's true.
Yes.
Oh, Jesus. No, but I have to meet you guys. It now work out. It really not work out though. Which day is your free day? Don't have any.
The only university we have to go from Monday to Friday.
No, man, it's not working out. I have to get you one day.
Sure.
Yes, please.
Sir, I can suggest something. What about the classes you said you would have extra? Can those classes you can have a face-to-face? Or is it that
Which day do you want to have those classes? Nobody don't tell me the day yet.
Well, I thought it was upon you, your decision, you would send it in the group.
Tell me the days that you are available. I can't tell which day I'm available, you know.
Me?
I'm available.
Sorry.
I'm available. All right. I can tell you the days that I'm available. But the days that I'm available, you may not be available. So I want the consensus to be from the class, and then I can work my way around that.
Oh, sorry, sir. I might need to rephrase what I just said. I remember you said that you wanted some extra time to go over some topics after the school would.
When school is completed on the 17th.
Oh, no, man, we can't wait so long.
Oh, we can't wait.
If I wait so long, Papa, me not going to ever reach the revision stage. I have something now because only now I know to differentiate. So therefore, the applications to differentiation are going to be a problem. Matter of fact, the next topic that I want to move into now is going to be a problem. And I still get moving tweets, you know, because me now sit down and wait. Because honestly, I'm not going to complain, so I never finish the syllabus.
So the only day we can see a Saturday, and then it will be a vote with everybody to say, are we willing to go on Saturday? So, you know, that is another voting thing and decision making and sacrifice for everybody. Because maybe not even everybody live in Kingston.
So I asked the Thursday and see what she said first, because it'll be easy for me, because the only day my work that Friday never
But also that must have students who are overseas.
Yeah, but it will just be switching time. So if she can
It's not come face to face.
It's not a matter of switching times, you know.
To school, but we are going to stay online at school. That is the only other option. If we go in at 7 on Tuesdays for Miss class, because Miss have overseas students, then we would have to stay at school from 7 to 9 online. Because you have to consider the persons who are not in Jamaica.
And that is true. So the owners then. So I don't necessarily have to speak with Mrs. Dennis Speed. If you guys will be willing to stay on campus, or if it is that you can be in commute, for those of you who drive, because I don't want nobody to take no taxi or no bus and on a phone in a class. If for those of you who drive and can conduct those classes or that class in commute, I wouldn't have a problem. And those of you who don't drive will just stay put in the same lecture room that I will find, you know, just to conduct. I have to meet you guys. It now work out, students. Real talk.
just one day I used to come to school and did it till 9 o'clock. I don't think I want a big problem. But not for me. I'm willing to come.
What about the others? What about the others? Honestly.
We may live 5 minutes from school, but just to consider other students, I don't know how it will work out for them. Some of them work.
All right, let me ask a question now. Because I need to finish up this and I must start my other summer. This is 5 to 9. Lotto, how you stay? Available?
Some good that you was told me you work from school, you know.
Okay, good. Crosswell, where you stay?
Crosswell,
No worry about that.
All right, good. Ashanti, how you stay? Well, no, next, utterly next. Come on, how you stay?
Sir, I live tavern, sir, and sometime must be around.
Hopefully, that's the way bus and still they will reach up.
Croswell, if I give you a lift to Manor Park, you think if, well, then again, no, it may not even be conducive because you're going to have administrative come afterwards. So it would not even be conducive.
If he's
Chelly,
okay, I could give him a ride because I'm coming that side. I'm going to Manor Park. I'm passing there. So if not, and he wants to drop at halfway tree, I can assist him to halfway tree as well.
Okay, thank you, Lotto.
Okay with him.
Okay, thank you, Lotto. Chelly, how you stay?
Sir, I'm good for anything.
All right, nice. Dan, how you stay?
Sir, I agree on the time.
Now I hear you.
Sir, I agree on the time.
Okay, you agree. All right, good. Dan, no. So when again, how you stay?
Yes, sir. I'll make it.
You make it good. Jojo?
Yes, sir.
Okay, I guess that's a yes. Michael?
Sir, no, sir, I'm sir,
no, guess what? I'm voting. And you say yes, sir. Does that mean you vote yes? Michael?
Sir, you called my name, so I'm answering you.
Whatever. Mikey?
Sir, is it for the late class on campus from 7 to 10?
7 to 9. You know, listen. 5 to 7. What is wrong with you?
I'd have to find my way home, sir, because I live in Portmore, so I'd have to talk to my mom first. And for me to come home is only one bus I can take. So, yes.
5 o'clock to 7 o'clock?
Sir?
5 o'clock to 7. Already somebody is willing in class to give a lift to half a tree. So that one bus.
Do you have anybody who drives who live in Portmore can give her a lift?
That's another suggestion. Anybody here that drives that live in Portmore? All right, let's go. Courage, or you stay?
Sir, where I stay?
Yeah, you could make it on Tuesday?
Tuesday, yeah, after I close work, yeah.
Okay, thank you, hon. Because Mikey, you did say yes already, right?
Yes, sir, should be okay as long as nothing don't come up at work.
All right, good. Try no matter when nothing come up. Tell them say nothing now go come up. Raji, how you stay? Shonali, how you stay? Shana, how you stay?
That's not an issue.
Okay, great, thanks. Sovan, how you stay?
Can make it, sir.
All right, great. So far, I know everybody like them can make it so you know, and Tariq same live 5 minutes away. Tony, how you stay?
I should be okay.
Okay, great, thanks. There's another person that I don't. There's somebody else who had to facilitate with the mid-semester, but we must see her in a class.
Yeah, I'm just in the outside.
All right, so guess what, guys? Next week, Tuesday, at 5 o'clock, we will be having our class face-to-face. For those of you who have administrative come, it's one of two things. Either you're going to stay on campus and have your stuff. If you can move in commute, do the stuff. Listen to me. I want it to be very clear. We don't want none of uno. Matter of fact, anybody who is leaving campus at 7 o'clock, whether or not you drive, sorry, the non-drivers who are leaving at 7 o'clock should not go to the gate to stand up to wait on a transport. We are going to be carpooling so we can get to the nearest point. You know, one nobody go say a true Mr. Shan have face-to-face class where I may get held up at the school gate. So I beg of you, those of you who drive, make them wipe them foot and come into your car and do. Give them a lift to Crossroads, Harpetry, or if you're going Manor Park or if you're going straight to Portmore, you can just facilitate it. Please, I beg of you. Please and thanks. Here? All right, let's continue. All right. So, so what is going to happen now is, oh crap.
Sorry to cut you. You will advise us on the classroom that will be used, right?
No, it's because this does come up, you know. I forgot put into. I have to put in the request tomorrow. But to be honest with you, I don't think I will have a problem finding a room because most of the evening classes are online. Yeah, so I should have ample classrooms. I would say that we will stay on block A, where it is a little bit more central instead of going over to block B. All right, so we'll be somewhere block A. I'll be there before, so we can find our way together, and we can. The only other thing is that I know some people leave work at 5 o'clock, so some of you can come in late, but do. Beg them a little time for next week. I'm not asking to come every Tuesday. Just beg them a little time next week. If we can leave half an hour earlier, so that you can get there for 5 o'clock, so we can have a solid 2-hour class. I'd appreciate. Please and thanks. What I will do nonetheless, you guys are computing students, come early so that we can, I want to mind if I could get one of the labs, so that I will still set up my Zoom link and everything so that, and turn the camera to the board. Uno can facilitate me with that. One of the technology people do. So at least, even though you're going to be in class, you will still have the recording to go through at some point later. But I still want it to come in. I don't want anybody to be online. I want to see you face to face to do the stuff. But all I'm saying is, those of you who may have your gadget, maybe a tripod stand or something that you can really set up something nice to teach her for him, go ahead and do it for me, please. Don't all rush me at once. Just go ahead and do it. So I still can record the lesson so that you can you can have it sometime later to review. Because if not, it means that what I'll be doing on Tuesday, you'll just have to recall from memory. And I really want you to have a record of it. All right? Thank you. All right. So
Sir, one more important thing. Ensure you have a bag of tigers. Okay?
You know, I don't like, you know, officially today, I don't like you. All right, no, man, I can carry tigers, man. Anybody work downtown? No?
No.
All right.
Selling halfway at Crossroad.
You work Crossroad? All right, Lotto, may I have your talk?
Crossroad.
Chat to me sometime tomorrow, Lotto. I'll make some arrangements because I carry tigers.
Not tomorrow, sir. I'll go off tomorrow and Monday. So I'm not going back until Tuesday. But I can grab someone. I can grab someone till I reach the school.
Okay, then. So just talk to me. Yeah.
All right, no can remind me.
All right.
Of course.
Cool. We'll have with tigers and we'll eat with tigers and we'll do a class. Yeah. All right, let's go. So this is what it is that we're going to be doing. So I am rewriting my stuff as a positive index. So I now have 2x plus 3 to the positive a half. But remember, to the positive a half, I can write the square root sign. So I'm going to have 1 over the root of 2x plus 3. 1 over the root of 2x plus 3. And that is it. The piece is done. Now, where I asked you, Rajay, wake up. Where I asked you to look at the stuff is when I gave you the product rule just now. And I'm going to go through the solution that I have here for the product rule, step by step. And I'm going to ask that you just give me your undivided. Just focus on the screen. If you're not seeing something, don't wait until I finish. Stop me so I can go through the stuff. So the question says, y equal 2x to the 5th, the root of x squared minus 1. You are multiplying Your first term is 2x to the 5th power. Your second term is going to be the root of x squared minus 1. The root of x squared minus 1. So what is going to happen now? I am going to be converting my square root of x squared minus 1 to x squared minus 1 raised to the 1/2 power. That's what I'm doing. Every time you get a square root question, convert it to the term raised to the 1/2. Every single time, barring none. Barring none. All right. And of course, we're using the product rule. We're using the product rule. The first times the differentiation of the second plus the second times the differentiation of the first. Watch this. Let me spotlight so that you see exactly where I'm at. Oh, Jesus. I'm going to start the other topic and I have to start the other topic. Oh, Lord, help me. Let's go. The first, I write it back. Times the differentiation of the second. 1/2 in front of here, so C here, so x squared minus 1 to the negative 1/2, C right here. So why the negative 1/2 again? Because it's this half minus 1 to give me negative 1/2. Times the differentiation of what is on the inside. The differentiation of x squared minus 1 is going to be 2x. The differentiation of a constant is equal to 0, so negative 1 goes to 0. So I'm going to have 2x right here. Plus the second, x squared minus 1 to the 1/2, times the differentiation of the first. 5 times 2 is 10. X to the 5 minus 1 is x to the 4. So in blue ends my differentiation. What I'm here doing now is fixing it up. Watch me.
Sir, before that, sir, you can run it back, sir, in blue from start.
No problem. The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. That's what the product rule says. First times the differentiation of the second plus the second times the differentiation of the first. So what I'm doing here is the first, C here, so, times the differentiation of the second. This little dot here means multiply. I'm differentiating the second. The second is a power rule. So how you know the power rule again? Any term raised to a power other than 1 has to be the power rule. So what's the difference with the power rule? Because you're using the same differentiation. The difference with the power rule is that you are going to be multiplying by the differentiation of what is inside the parentheses. So it's going to be 1/2. This half is going to come in front of the something here. See here, so just like you differentiate it normally. And then you're going to subtract 1 from the power. So it's going to be 1/2 minus 1 is going to be 1/2, negative 1/2. The difference with this now and the other ones is that you now have to multiply all of that by the differentiation of what is on the inside of the parentheses. And when I differentiate what is on the inside of the parentheses, the differentiation of x squared is going to be 2x. Sir, but you have a 1 there. Yeah, I know. I know that. But the differentiation of a constant is equal to 0. The differentiation of a constant is equal to 0. So I'm going to multiply by 2x. This now ends the differentiation of this power rule. Then plus the second, x squared minus 1 to the 1/2, sit here, times the differentiation of the first. Watch this. 5 times 2 is 10, sit here, x to the 4th power, because we reduce this by 1, x to the 4th power. Because this x is just a single term and not a double term. It is not the power rule. This here is a double term right here. X squared minus 1 is a double term. I have 2 terms inside here. That makes it a power rule. Then, sir, what if I have three terms? Power rule. 4 terms, power rule. Differentiation ends right here. Fixing it up now. I have 2 terms. All of these, you see all of the multiplication here, this term is being multiplied by this term, which is being multiplied by this term, constitute 1 term. So all of this here is 1 term. Separated by my plus sign, and everything else here is another term. Remember now, terms are separated by positive signs or negative signs, not multiplication signs. So terms are separated by positive sign, which is why I can say to you that this is 2 terms. These are 2 terms because it's separated by negative sign. Down here, so are 3 terms because I have a positive sign here and a negative sign. So I have 3 terms. I have 1 term here. This is my separator with another term. But sir, why isn't 5 1 term and the x squared? No, because the 5 is being multiplied by the x squared. So my multiplication can't separate a term. It's just my addition or subtraction signs. Being separated, see, this negative sign is a separator and it gives me the other term, which is 5. So I have 1 term, 2 terms, 3 terms. 3 terms. All right, this one is 2 terms. How many terms do I have in here, so?
Sir, my unmute mic on 4.
1 term. 2 terms, sir.
2 terms.
Yeah,
Jojo,
that was it.
Says 2 terms.
Because
Because remember,
mine and 4 come out. I don't know why.
okay. Because remember, this 5 is being multiplied by the x squared minus 1 to the first. So I can't have a term with a multiplication sign. So all of this ugly looking thing here right here, so, you know, is a term. The 5 times x squared minus 1 to the first is a term. When I expand this out now, Dan, unmute Papa. But why am I jumping the question? But let me talk about it, because you asked a question. Dan?
Yeah.
All right, you're very low, Dan. Look here now. You recognize that teacher is multiplying this 5 by this x squared and this 5 by this negative 1 to give me 5x squared minus 5. You see it?
Yes, sir.
But you did ask teacher, sir, am I able to multiply? Lord, was it up here, so? No, it was the other one. Sir, am I able to multiply the half by the 2x? Remember you asked that question? And I said to you, no, you can't, because that term is being raised to the 1/2 power. Look at this one. I'm able to multiply throughout that because the term here is being raised to what power up here?
1, sir.
1. So the only way you can multiply, you can distribute the factor out here by what is inside the parenthesis is unless what is inside the parenthesis is being raised to the first power.
Yes, sir. But it wasn't me who answered the question, but yes, sir.
No, man, you're very low. Anybody can hear him?
Oh, sir, you can't hear him at all. It's like a whisper.
You hear
Talk
me
up, Dan. You're saying something?
Yes, sir. I said I did not ask that question, but I understand what you're saying.
Sorry. Who asked the question? Sure, so somebody asked the question.
Sir, I'm confused to how the 10x just disappeared.
I'm coming to you, Papa. I'm coming to you. Because somebody asked a question right here. Why did I not multiply this half by this x? Was it here, sir? I think it was here. Was it there, or is it a 2x? I think it was here. Somebody asked, why didn't multiply? Somebody said, sir, it's a question and I don't want it to sound stupid, or it to say, why didn't multiply this half by this x? Nobody don't remember that question? Hello, somebody?
Also, I remember.
Rockstone. Sitting around with me, man. Me know so somebody ask a question, you know. You see, on the way and listen to the recording, and on the way and know say it's not the voice that sir normally hear inside of his headspace, he's hearing tonight. I mean, no, the question was asked. But anyhow, whether or not it was asked, now you know that you can't multiply, you can't distribute the factor into this, except that it is raised to the first power. All right?
Yes, sir. I asked the question.
So, Bridget, you see, you hear me ask how long I know, like, you know, want to talk to teacher, make teacher feel like he might talk to himself. Sure. All right. Question now. You see what sir was trying to explain just now?
Yes, sir.
You sure?
Yes, sir.
All right, cool, Papa. All right, I'm happy. Because I know the voices in my head don't come out so early. They come out later on in the night. All right, let's go. All right, let's go. Where am I now, Lord? Somebody just asked a question a while ago about the 10x.
Yeah, about 10x. How it just like...
Okay. You see, I know I heard that one. All right, cool. Let's go. Let me start. Let me start from the blue and come right around. So I'm looking at the multiplications. I'm looking at all of these terms and watch me. 2 times a half is 1. Talk truth.
Yes, sir.
And 1 times 2 is? It's 2.
1 times 2.
Not a half, but 2. 1 times 2 is 2. Watch this now. X to the 5th times this x here is going to give me x to the 6th.
Yes, sir.
And all of this here with the power is all of this right here.
Mm-hmm.
And then now this 10x to the 4th. All I'm doing is just carrying it in front of here and put it back here and then write back the x squared minus 1 to the half. So really and truly what I'm doing here.
Yes, sir. I fully understand all of that, you know. It's just that after you go past that line that you're at now and go down, I'm wondering.
Oh, okay. All right. So that's where I was. So that's where I want to get to. Because that's where I'd asked the question and then I wasn't getting the answer. And it was at that point I asked to go and drink some water and come back. So if you recognize new share. Sorry. If you recognize, this is where I was, right here, so. I was just about at the point where I'm going to be factorizing and I wasn't getting the response. So I just stop and say, you know what? Go back to something that you already have. Come on, where are you? So that I can demonstrate exactly what it is that we're talking about. So watch me now. So Courage, I heard your response to me before when we just returned. I heard your response to me. And hear me out. I want all of it to read for me. What it is that I have in green.
Call.
Always factors out the smaller of the two.
Have you ever heard me say that in class before?
Yes, sir.
Yes, sir.
Okay, every single time. So I'm not going to give you a rule. That is a rule this minute, and the next minute it changes to something else. There are some rules in mathematics that what happened?
Oh, I see it, sir. Okay.
You see it now?
Yeah, man, I understand what happened. When multiply and you will get back everything.
Yeah, man.
Okay.
You see it now?
Yeah, man.
And I don't want to teach, I forget mental. Oh, no, good to me, you know? I mean, no, my teacher will do something, you know? All right, let's go. So as a rule, every single time, we are going to be factoring the smaller of the two. Every single time barring none. So watch me now. and watch me carefully. Don't write, don't blink. I am looking to see what is common between 2 and 10. And the answer is 2. I'm looking to see if there's anything common with this x to the 6th power and x to the 4th. Yeah. But I'm going to take out the small of the 2. So I'm going to take out the x to the 4th. I can't take out x to the 6th because I have to take out the smaller of the 2. So it must be x to the 4th. So I'm taking, because remember, all of x to the 4th is contained in x to the 6th. Talk truth. Yeah. All of x to the 6th is not in x to the 4th. So I can't take out x to the 6th. So I have to take out the smaller of the 2. So I'm going to take out x to the 4th. See it here, son? And then I look and I say, but hold on there. X squared minus 1 and x squared minus 1. But no, sir. The base them look similar. X squared minus 1 and x squared minus 1. Why them look identical to me? Oh, but hold on there now. One of them is to the positive a half, while the other one is to negative a half. You know what? I am following the rule. Sir says, always take out the smaller of the 2. A sir says so, and can't mark it wrong, or else we have to have conversations. So I'm going to take out the smaller of the 2. Which is smaller? No, the negative a half smaller.
Yes, sir.
So we take out the negative a half every single time. So watch me now. Watch me. There will be nothing else that is common. So that's how I draw my square bracket. Sir, why put a square bracket? I put a square bracket because whenever I'm having a bracket containing in another bracket, I normally use different types of brackets so that you can see what it happens. So if I had another bracket inside here, then you still may use the curly brackets, right? So you can see the different types of things that I'm enclosing in the brackets. Work with me now. So I now need to find what term is left in this piece here. So watch me. I'm going to work it back ways. X squared minus 1 to the negative 1/2. I already have right here. I have x to the 4th, but I need x to the 6th. It means that I need x squared more. Talk truth.
Yes, sir.
So I put the x squared right here. Sir, me not see that. X squared times x to the 4th is x to the 6th. When I'm multiplying and the bases are the same, I'm adding my powers. 4 plus 2 gives me 6. And the 2 is right here. So I know I have everything fit now for the first term. Let us check the second term. What do I multiply by 2 to give me 10? Your answer is 5. What do I multiply by x to the 4th to give me x to the 4th? So 1.
1.
Good. So there's an imaginary 1 that is being multiplied by the 5. But we don't write it because 1 is known as a multiplicative identity. So if I multiply 1 by 5, I still going to get 5. So I leave it alone. Watch me now. This is where the trick comes in. I now need to get x squared minus 1 to the positive a half. I have a negative a half out here. But watch the trick. When I'm multiplying and the bases are the same, I'm going to add my powers. So again, write back to something with the base. Negative a half plus 1 is going to give me positive a half. Talk truth. So that's why I'm going to raise this x squared minus 1 to the positive a half. Let me say it one more time. Why am I using a positive a half? I'm using a positive a half because when I add that positive a half to negative 1/2, I'm going to get positive a half up here. Watch me.
Sir?
Go ahead, Papa.
So in other words, all that is in the square bracket is the common factors between each factor that you're saying.
It's the other way around, Dan. What I factored out, the 2x to the 4th, x squared minus 1 to the negative a half, is what is common in this and this. What is in the square brackets is what is left. Got me?
Trying.
So what I'm saying to you, so I think you get it to know, but it's just that you use the wrong terminology. It is not what is in the square brackets would be the factor. Is what I would have taken out would be the factor, and what is left is going to be the square brackets. Look at it. The 2 is common here, and the 2 is common here. So we take out the 2. The x to the 4th is common to x to the 4th. It is also common to x to the 6th. So I take it out. And this x squared minus 1 to the negative 1/2 is common to both of them. So I take it out. So all of this outside right here, so would be my factor. See it here? Always factor out the small of the 2. So I'm factoring out these.
Sir, you know, I finally understand it.
Say it again, Papa?
Yeah, I finally understand it now.
Okay, good.
Yeah.
All right. All right. So what I've just done is to highlight, ouch. What I've just done is to highlight the factor for you. And I don't like what I use the highlighting because I want to show you something that is different. I normally use those 2 colors. So what is in pink there, or magenta, whichever one you want to call it, would be the factor. What is in the square bracket is what is left. And what is left? Normally, let me answer a question. Normally, when you have leftovers from Sunday, Monday, what do you do Wednesday?
Warm it up.
Usually,
you know mix up everything.
Wait, is it Sunday leftovers and they did it until Wednesday?
Oh, you don't have leftovers that long? Oh Lord, it tastes nicer.
No, I don't keep leftovers that long. The food tend to lose it.
Yeah, man. But anybody ever warm up like curried goat and fried chicken and or stew chicken together? Or you have to warm them in separate pots?
No, not together with the rice, everything mixed up.
And you just mix it up, don't? All right, guess what? That's why I mean like maths, because maths is real life. So this is the curried goat part, mixed up with the fried rice, and you have some white rice before, and you put the white rice on it. And then guess what? Lotta's favorite stuff. She got have little ackee and saltfish left over from the lunch, and she throw it into the pot same way. And she have a kaleidoscope of stuff. So inside the right here, so is all the leftovers. And the leftovers are going to be warmed in one pot. See it here, so the square bracket here, so. And they will be combined into one nice stuff. Look how the combination going to go. It's maths, it's real life. The x squared is the only term on this side. So we write it back. Because this is raised to the first power, I'm going to distribute this 5 over here. 5 times x squared is 5x squared. 5 times -1 is -5. And then when we check a stop now, me say, all right, me go put all of the meat them on one side and everything else on the other side. I know all bad too. Get little leftover dumpling and fry it, man. Jesus, Father, nice fried. Watch me. Then I go put the leftover dumpling to the one side. Because guess what? If me have rice and leftover fried dumpling, me go eat the fried dumpling last. Because the part is too nice. I'm going to eat it enough of the meat. And then eat off the rice. Watch this. Me add them two something together. X squared plus 5x squared is 6x squared. Sir, or you get that? X squared is the same thing as 1x squared. Talk truth.
Yes, sir.
Yeah, man, and 1x squared plus 5x squared is 6x squared. See that, so? Boom. And then we have the -5, so. All right? And then now, this could almost be my answer, but we don't write our answer as a negative index. We never normally do. So what I'm going to do is to pull this piece here with the negative index into the denominator and call it positive. See here, so the 6x squared minus 5 is remaining in the numerator, so will be the 2x to the 4th. So all of those are going to remain in the numerator. And then now, this denominator here can be written as a root of. So you notice everything in the numerator remains the same. See here, so everything remains the same. I'm just reconverting the denominator, the x squared minus 1 to the half as the root of x squared minus 1. And that's my final answer. Wow. I feel like I just run a marathon.
Sir, I got that for my answer before you finish.
Bless the Lord, oh my soul. Thank you, Jesus. All right. Again, press pause. I am going to be very nice tonight, and I'm going to send you, should I send you the solution or just send you the question?
Question and solution.
All right, so I'm going to send you my example 4, my example 5, so that you can work through those. This is some bigger stuff. I mean, I'm sending that one. No, I'm going to send it to you so you can see.
Can we go on number 3 so you can screenshot it?
You want to see the number 3? All right, no problem.
Let me just work out.
All right, let me reduce it somewhat so you can get the full. Oh Lord, one more time. Hold on.
So you can send the question and solution and then send a new question where you create. One,
I could do that.
Please, one for next class.
I could do that.
Have to be one, just joking. Can be as many as.
You have jokes at 10 o'clock at night, eh?
Yes, I can scroll over.
All right, thank you, Papa. All right, I'm changing gears. I'm changing gears. Whoa, it could have passed paper here. Jesus, what a way the man them wicked to honor. This is 2013, December. You see what I'm saying? Differentiate this with that. With respect to simplified 4 marks. It's a good thing. See, I have a nice teacher. We do the question already.
My Jesus.
See me, so. All right. I need to move into this, guys. I have half an hour. Again, press pause. You see those questions that I've previously worked, including the past paper, I'm going to send them to you. I think that was Mikey a while ago, asking for the additional questions. I'm going to send you into the past papers to get those additional questions because I don't want to make up the question. I ain't got things say, not a question I go come like this, yeah, sir, just too extra. Oh, but here, you see, all of what I was doing earlier on, I didn't even recognize that I have it right here. You see, guys, when I make up the story, you know, everything that I did this morning, tonight. See here? It's here as a summary. Look at this one here. I'd prefer if you go into the past papers. I'm going to tell you why. I am sure if I made up this question, you're going to say, sir, extra, them not set no question like that. When you see it on a past paper now for yourself, you're going to say, you know what? I saw the question them going to come. And they're there on the past paper.
This question was on Microsoft.
There you go. But you see, let us not even say that because people are not going on to do their Microsoft work, so they won't know.
That is where I'm at, sir, and a lot of them is there.
Yeah, man, absolutely.
Unit 3.
Mm-hmm. All right. So, implicit differentiation. I have to start this. So let me just introduce this. I'll come back to it on Tuesday when we meet face to face, God's willing. But I have to introduce it. If I don't introduce it, I'm going to feel like a failure tonight. Because really and truly, I planned initially only to spend a half an hour, not an half an hour, sorry, an hour on what it is that I just completed. All right, so let's go. Let's hope the time spent is not wasted. Implicit differentiation. So a function can either be implicit or explicit. An explicit function is of the form y equal some function of x, and even x to the n. That's an explicit function. That is, when we know x, we can calculate y directly. An implicit function is of the form some function of y and x equals something else, meaning that this is going to be something that includes both x and y. Knowing x does not necessarily lead to an answer for y. All right? So let us look at the steps involved. Matter of fact, let me ask you to just read, let me bigify it. Let me ask you to just read those steps involved. I give you a minute and a half to read those steps involved. All right. So the steps involved in this type of Jesus, did sir write that? Buck up, you know? Oh my goodness. So you're going to differentiate the function with respect to x. Therefore, when you see a y, I don't know what buck up in, but yeah, if you want to say it, when you buck up in a one y, you have to include the dy by dx. You will see what I'm talking about after. The next step is that you're going to collect all the dy by dx on one side. Then you're going to solve for the dy by dx. This part is optional, depending on how the question is worded. If the question gives you a point, and the point is written as x comma y, you know, like 2 comma 3, where x is 2 and y is 3, then you're going to substitute the coordinates into the differentiated function to evaluate dy by dx, to evaluate what your dy by dx is going to be. Those are the 4 steps. All right. So let's see what can happen. It says if x squared plus 3xy plus y squared is equal to 16, we need to find dy by dx. And at this point in time, if you get frustrated with you having to do calculus 1, I can understand. Lotto, you know, I know, so yes, that the first thing come to your mind, you know, why did I get to this point? Well, guess what? It really isn't bad. It really isn't bad. Work with me. Here goes your question. So I'm supposed to be differentiating. So I'm going to be differentiating normally. The only time I'm going to include a dy by dx is when I buck up into a y. Watch me. So I normally do this in terms of, all right, let me ask a question, because I mean, if I do it this way, you may get it. It's if you're single, either male or female, you don't have to give no explanation to anybody when you want to go on a road. If you're single, if you're a male and want to go on a road, you put on your clothes and go on a road. Nobody can ask you not because you're a big man. If you're a woman, you do the same thing. But guess what? It's when you're married, you can't just get up and say, I go on a road. You have to go say, where you go. So if you're a female, you can't just go and say, oh, ask me there. Oh, no. Where are you going? And if you're a male, you can't go, oh, hell no. Where are you going? So when you are married, you don't have all the say. You have only half the say. And please, that's the example that we're going to be using. I don't want any married people in the class going to tell me, say, oh, sir, me run my show. That's not the idea. Look here. This x squared is single. Why? Because it's just x squared. You see this 3xy? Married. Because they have an x and a y together. What do you think this y squared is? Married or single? Hello? I'm not hearing you. Anybody speaking? Are you hearing me?
Speaking, sir.
Yes, sir. We're hearing you.
Yeah.
Yeah, so now answer me then. Now ask if the y squared married or single.
Single, sir.
Single. Single. So the married people are the ones with both x and y together. And the single ones, this could be a single male or it could be a single female. This could be a single male or a single female, depending on which one is called the X or Y. But for sure, you know that one are married because the X and the Y are together. Do you get that concept? All right?
Yes, sir.
All right, watch me now. When I'm differentiating x squared, I'm going to get 2x. Talk truth.
Yes, sir.
Yes, sir.
All right, see it right there. So boom, I get the 2x. I am differentiating the married people. Them know. Watch me. I am differentiating the married people. And I'm doing this one. I'm differentiating this one conventionally first, and then I do the other one the next time around. The first is going to be the 3x. The y is going to be the second term. So the first 3x here, the first, times the differentiation of the second. Now I'm differentiating y. But whenever I buck up into a y, every time you differentiate a y, write dy by dx. So you see, when I differentiate this y and I get 1, I have to write dy by dx. Plus the second, remember y is the second, you know? So plus the second times the differentiation of the first. When I differentiate the first, I will get 3. And then plus, I'm differentiating y squared, it's going to be 2y. But whenever I write a y, I'm going to put dy by dx. So it's going to be 2y dy by dx equal. When I differentiate a constant, I get what?
0.
0. See, man, see there? Boom, 0. Differentiation ends right here. So it's the same sort of product rule. Ah, sir, how do you identify the chain? The chain is separated by positive signs or negative signs. But in that separation, I can always have a quotient or a product or a power rule. In this case, I have the product rule right here. So in between, differentiation of a constant is equal to 0. Watch me.
Sir, so what is that 3x? 3x y. 3xy, the second.
This one?
Yes, the second function. Just go back a little on that for me. Please.
All right. So it's the first 3x times the differentiation of the second, which is a y. Oh. So when I differentiate y, I'm going to get 1.
And then so we have y.
And anytime you do y, dy by dx must be written every time. Then plus the second, plus y, times the differentiation of the first. The first is going to be 3x. So the differentiation.
We're using the power rule there, sir.
Not the power rule.
The product.
The product. Yeah. The product. You see, every time it's a power, it sounds like, every time it's a product, it sounds like power. Yeah. So using the product rule, right? So it's the first times the differentiation of the second, plus the second times the differentiation of the first. And then now I'm differentiating y squared. And the differentiation of the y squared is going to be 2y. But because it's y, you have to write dy by dx.
But you still have to put the differentiation of the y, then you add the dy.
Absolutely.
Okay.
Absolutely.
But I don't want to think that I must replace the y. So I'll just 2 dy over dx. 2y? No, I said I don't want to think that way. That's why I said I must still do the differentiation of the y squared. Yes. And then add the dy. Put it beside it then now, multiply it beside it.
Same way, so. So watch me now. I'm just rearranging right here. I'm rearranging right here. I'm going to go through this in another 5 minutes and then we'll call it a night, yeah? And I will get back to it, so don't have to worry about it. Just try and get some understanding to it. So I'm rearranging. 3x times 1 is just 3x. So I'm just going to write it as 3x dy by dx. Y times 3 is 3y. So I just write it as 3y. 2y dy by dx is exactly as it is. 2y dy by dx equals 0. Remember the condition. The second condition now was that we're going to collate all the dy by dx's on one side. So that's what I'm going to be doing. I'm putting all the dy by dx's on one side. So look here. See there? All the dy by dx. So you see what I've done? You see this 3y? I'll move it up right here. So you see it? And then now the 3x dy by dx and plus the 2y dy by dx, then they're close to each other. Why, sir? Because I'm going to factor out what is common. What is common is my dy by dx. When I take out the dy by dx, I'm going to be left with 3x plus 2y. See it right in this one? 3x plus 2y. And of course, I'm going to have my equals 0. And of course, I'll have my 2x plus 3y right here. What I'm going to be doing now, because I want the dy by dx to be on one side, I'm going to subtract 2x, 2x plus 3y. I'm subtracting 2x plus 3y. I'm going to subtract my 2x plus 3y. So watch me. That's why I have this negative sign outside here. Negative 2x plus 3y. And if you don't see it like this, look at what I'm doing. This is a positive 2x. So when I subtract it from both sides, it becomes a negative 2x. This is a positive 3y. When I subtract it from both sides, I'm going to have a negative 3y. So this piece here, so, and this piece here is the same. All I'm going to do now to find dy by dx is to divide both sides by 3x plus 2y. See it here, so? I divide both sides by, so I'm just going to have a 3x plus 2y under here, so. And that's that. Ask me your questions, and then that takes us to the end of the class. I'm not doing anything more than that. Just ask me your questions now. It takes us to the end of the class. I will send this question to you also when I'm sending this stuff a little later on.
Thank you, sir.
No problem. Any questions?
Sir, I'd love if you could use the 2 minutes and probably go back through.
I have no problem. Pleasure is mine. Pleasure is mine.
Sir, I don't understand the last part. How did it change to a quotient?
Because I have what I have is 3x plus 2y times dy by dx. I want dy by dx to be the subject. So because dy by dx is being multiplied by this, I'm going to divide both sides by.
Okay.
Right. All right. So going over one more time for the class. So the question says, and a question like this sometimes comes for 5 marks. Sometimes 7 marks too. It says, if x squared plus 3xy plus y squared equals 16, find dy by dx, not a problem. Or implicit differentiation. Implicit because you have the x and y mixed up together in order something. You don't have a straight function like we normally have. Watch me. This is an explicit function because you have y on one side, and then on the other side, you have the x star root. You see that?
Yes.
Here, on the other hand, you don't have, come on, you don't have y on one side being equals to some x value. You have x and y mixed up. You have x and y mixed up together. All right? So we're differentiating. So the differentiation, so we're differentiating everything as it is. The only difference now is that whenever I buck up into a y, I'm going to write dy by dx. When I buck up into a y, I'm going to write dy by dx. Work with me. Differentiating x squared, I'm going to get 2x. See here? 2x. I'm differentiating 3xy. But 3xy is a product. So I have to use the product rule. The first times the differentiation of the second plus the second times the differentiation of the first. The first is my 3x, so I put it back. Times the differentiation of the second. When I differentiate y, not y squared, but just y, the differential of y is 1. See it here? But I have to put it times dy by dx. Every single time I buck up into a y, I must put dy by dx. Plus the second, plus this y, see it here? Plus the y, times the differentiation of the first term. And the differentiation of 3x is 3. See it here? No, I finish it, you know, because product rule says the first times the differentiation of the second, plus the second times the differentiation of the first. Then now plus the differential of y squared. When I differentiate y squared, I'm going to get 2y. But because it is a y, I have to put dy by dx. Equal, this 16 is a constant. If they had 16x, I would have differentiated it and would have gotten only 16, but because the constant is going to be equal to 0. And in this line, all I'm doing is just fixing up. All I'm doing is fixing up. All I'm doing is fixing up. 3x times 1 is 3x, dy by dx. Y times 3 is 3y, plus 2y dy by dx equals 0. So I'm just sticking out the multiplication dots inside here and just fixing it up so I can see what I have. And then my aim now is to always put the dy by dx's together. So I recognize that this 3y is in the midst of the dy by dx. So I just pull him over in under something. See me so? Pull him out of here so and put him closer to the 2x. And then now that will push these two dy by dx's together. But because I want to find dy by dx as the question asked me to do, I'm going to factor out the dy by dx's from these two terms. So I write about my 2x plus 3y right here. Then I'm factoring out my dy by dx. So when I factor out my dy by dx, this is what I have. I'm going to be left with 3x plus 2y. See it right here, so? So what is happening now is that my dy by dx is being multiplied by my 3x plus 2y equals 0. Equals 0. I need to make dy by dx is subject to the formula. I can't separate the dy by dx to the 3x plus 2y just yet because these are being multiplied. So now I need to get rid of this 2x plus 3y. Because this 2x plus 3y is being added on this side, I'm going to subtract it from both sides and it becomes a negative 2x on this side. Similarly, this 3y is being added on the left-hand side. So in order to get rid of it, I need to subtract it from both sides. It becomes a negative 3y. So what I now have is dy by dx is equals to, dy by dx times 3x plus 2y is equal to negative 2x minus 3y. In order to find dy by dx, the opposite of multiplication is division. So I'm going to divide both sides by 3x minus 2y. It would cancel this side, but it's going to remain here over 3x plus 2y, and that is going to be my final answer right here. Clearer?
Yes, sir.
Right. So you may not understand it yet, but at least it's a little bit more logical to you. Give me a few minutes. Normally when I finish my 10 o'clock, I just kind of lounge a little bit. Sometimes I sleep a little bit and get up and just reflect on the class a little bit and then sort out myself. So I'm going to send this off in a few for you. Guys, just remember, please, I desire success for all of you, not just some, but for all of you. But if you fail to prepare, prepare to fail. You can't want 6-pack and don't do no workout. And that's what I keep saying to myself. That statement was for myself just now. Forgive me. You can't want pass the course and not practice the math. All right. So it's been a long class. It's been a long day. Sleep tight. Get some rest. Get up and do some work. Yes, please. Go ahead.
So can you let us get this recording before the weekend?
Yeah,
or over the weekend?
You didn't get the last recording before the weekend?
Sir, but talking about this one.
Oh, okay then. Oh, no, it's just that the way you ask it is as if the recording is coming later. No, man. By the way, you got the last recording to do, no? Right? Yeah, no?
Yes, sir. I got the last recording.
Okay, yeah, man. As soon as this one comes in, I will send it off to you. All right. Bless your heart. Take care, guys. Take care. Talk to you.
Okay, sir. Take care.
Take care.